Hey, what's up? Welcome back to this new video. This one is paper 1-3 of November 2022 for paper Add Math. Now, with that being said, obviously, let's move on to the questions. Number 1. So here we have what? On the axis, we have to sketch this graph, y equal to 4 sine 3x minus 2, 4x between this and this. Now again, this one is pretty simple. We just have to use a table of values. So how do we do this? We take x and find the corresponding value of y. Now again, we have the graphs given to you by these values of x on the axis. So let's use them. Why not? You'll have plug those in your table and then find its corresponding values on the graph. Let's see what happens. Okay. Obviously here we have to be using radians. Okay, so when x is equal to minus pi over 3, so we have 4 sine of 3 times minus pi over 3 minus 2. That should be minus 2. Now when x is equal to minus pi over 6, let's see what happens. So we want to replace that. That should be minus 6. When x is equal to 0, so this will become 0. 4 minus 2, so this whole thing will become 0, become minus 2. Now pi by 6, we have what? We have 4 sine of 3 times pi by 6 minus 2. Give you 2. And then what else? We have pi by 3. Minus 2. Okay, so here you go. We have a few values that we can use to plot on the graph. Let's see what happens. So first point is minus 2. So minus 2 will be right here. Second point will be minus 6. Minus 6 will be at the bottom. And then we have minus 2 again right here. Then we have 2 should be right here. And the minus 2 should be right here. Okay, as you can see, this will be the shape of my graph. So let's try to join those with a smooth curve. So try your best. Again, use a pencil, obviously, because if you make any mistakes, you can always correct it on the graph very easily. This is my max point. So it should look something like this. Alright. Almost done. Something like that. Something like that. Okay, here you go. And then you can just label your graph, but that should be fine for your question. Number 1, using a table of values to draw your graph. Now let's move on to question number 2. We have to show that this can be written as this, where a and b are exact constants to be found. Now again, it is up to you. You can always complete the squares, or you can always expand this and compare coefficients. For example, I can say this is equal to what? 2. That will be x squared plus 2ax plus a squared. And then plus b, I can say this is 2x squared plus 4ax plus 2a squared plus b. So now we can compare coefficients. So this is this, which means this have to be this, which is just 1, right? So 4a is 1, where a have to be 1 over 4. And the last one here has to be this one over here, which is 2. A squared is 1 over 4 squared plus b has to be minus 15. So simplify. That will be 2. That should be 1 over 16. Plus b has to be minus 15. So continue over here. B will have to be minus 15 minus 2 over 16. Let's see what happens. So minus 15 minus 2 over 16. That should give you minus 15.125. Or you can write in terms of a fraction as well. Minus 15, 1 over 8. Hence, we have to express this in this. You write this becomes 2x. We have a, which is plus 1 over 4 square minus 15 1 over 8. This will be your answer for question part 1. Now let's move on to part B. Part B will be what? Hence. So hence meaning using part 1, write down the stationary point. So we have to understand that once we express this as this, we should know the stationary point. We have to look inside and the last value over here. So the x value will be, we take x plus 1 over 4, we equate that to 0, which means x will be 0.25, and the corresponding y value should be this one, which is minus 15.125. So the point, stationary point, will be 0.25 and then minus 15.125. Obviously this one will be what will be, since the coefficient of x squared is positive, it will be a minimum curve, right? Now let's move on to part C of your question. On the axis below, we have to sketch the graph, this modulus graph again, stating the coordinates of the points where it meets the axis. Pretty simple, but first, as always, we first ignore the modulus. We will consider the usual graph, which is this one, right? Now at the x-axis, the value of y, so at x-axis, what do we know? Y has to be 0. You will have 2 x squared plus x minus 15 have to be 0. So factorize. That will be 2x times x. 15 is what? Is 5 times 3, so 3 here and 5 here. To get plus 1, we have to have plus 6 minus 5. So x will be 2.5, x will be minus 3. Now, if I want to find where it cuts my y-axis, of course, at the y-axis, what do we know? The value of x have to be 0. Replace back, you will have y is equal to 0 plus 0 minus 15. That will be my y-intercept, which is 0 minus 15. Now again, this is just a sketch. We don't need to do everything exactly accurately. We can just sketch in this graph. Again, at first I am drawing the graph without the modulus. This is not the final answer. Okay, so let's pretend 2.5 is somewhere over here. Right, 2.5 is somewhere over here, and 3 will be somewhere over here. Minus 3. Minus 15 will be somewhere over here. For example, right, let's pretend. And then, of course, what the hell do we have to do? We have to have the minimum point, which is this one, 0.25, and then that should be somewhere over here. That's the minimum point, which is minus 15.125. Okay, so let's join that to form our curve. So it should look something like this. Let's try your best. So it should be something. Okay, mine is not the best, obviously, as you can see. Should be using a pencil so that your curve is as smooth as possible. This is my first draft. Obviously this is not my final answer, but I do understand that modulus, now we have to apply modulus. Modulus just means everything which is below has to be reflected upwards. So basically this point, so this was what, 1 to 2.7 has to be reflected upwards. 1 to 2.7 should be right here, and this one was 1 to 3, so 1 to 3 should be reflected upwards. So everything below will go upwards. That's the main idea for modulus curves. There you go. So basically, after I'm done with this, I will erase the draft, which is the black ink, I will only leave the blue as my answer. Okay, so my answer will be only the blue ink. This will be gone, and I will write this is my graph for y equal to modulus 2x squared plus x minus 15. Okay, now let's move on to part B, part D of your question. We have to write down for which value of k, for which the equation, this is basically y, is equal to k, has 3 solutions. Obviously, we understand that y equal to k, it is a horizontal line. So we just want to know at which point we can draw a horizontal line and it will cut our graph at exactly 3 points. So pretty easy. By observation, obviously, if you were to draw a line here, you will cut my graph as 1, 2, 3, 4 place. But only this place at the maximum point. Sorry, it's not maximum point. At this point, you will have 1, 2, and 3. So basically, when k is equal to this point here, which is what? Which is 15.125. When k is equal to this, I will have exactly 3 solutions. Otherwise, it will be just 2 on top, 4 and 2 solutions. This is the only point where you have 3 solutions. Again, this is done by observation, by using your graph. This is your question number 2. Now let's move on to your question number 3. So we have to solve the simultaneous equation. So find the values of x and y by using these 2 equations. So what I can do now, I can make x become subject. You will have 1 over 2y. Now we have to replace in this equation. So here we have 3y minus 2x. X is 1 over 2y plus 2 have to be 0. Now simplify, this will cancel out. You will have 3y over 1 over y plus 2 have to be 0. Now to eliminate this y at the bottom, I can multiply everyone by y. You will have 3y minus 1 plus 2y. 3y squared actually, right? So you will have 3y squared plus 2y minus 1 is 0. We can factorize. You will have 3y times y. 1 is just 1 times 1. To get plus 2, I have to have plus 3 minus 1. Obviously, this is how you multiply these brackets. You take the first one, multiply by the last one. So 3y multiply by plus 1 to get plus 3, and then minus 1y to get plus 2y. So that's how you factorize this. Okay, if you can factorize, you can always use your formula to find the values of y for a quadratic equation. So here y will be 1 over 3, y will be minus 1. So find the corresponding value. So x will be what? 1 over 2y. X will be 1 over minus 2, which is minus 0.5. Okay. Now for this one, it will be what? X will be 1 over 2 over 3, which is simply 3 over 2, which is 1.5. So let me write this down. So we have 2 possible solutions when x is equal to minus 0.5, y is equal to minus 1. When x is equal to 3 over 2, y is equal to 1 over 3. So this is my solution for question number 3a. Now let's move on to part B. So here we have to solve this equation, giving you answers as powers of 3. Okay. So let's do this. So here, as you can see, we have log base of 3x, but here we have log base of x3. So it's not easy to work with. We have to change that to log of base 3, so our life is easier. So by using the laws of logarithm, I understand that I can rewrite this as log the base 3 of 3 over log the base 3 of x. This is equal to this by the laws of logarithms. You have to know this, eh? So now I can replace. So this is just 1. So log of one value, taking the same value is just 1 over. This is 1, and this will be just log 3x. I can replace. You will have log 3x plus 3 is equal to 10 times 1 over log 3x. Now definitely this looks kind of scary, so what can I do for now? I can say well, let y equal to log base of 3x. So you will have y plus 3 is equal to 10 times 1 over y. Okay, so now it's not too bad. It will become what? Y plus 3 will be 10 over y. I can obviously cross multiply, right? You will have y squared plus 3y is equal to 10. Send this over here, you will have y squared plus 3y minus 10 is equal to 0. Now obviously I can continue on this side, so factorize. That will be y times y. 10 is 5 times 2. To get plus 3, I have to have plus 5 minus 2, sorry. So y will be the value of minus 5, or y will be the value of 2. But again, I'm not trying to find y, I'm trying to find x, so replace this back. Log 3x is this. So x will have to be, I have to send the power here, 3, this one, and this one will be same thing. You will have this, so x will be, send the power at the base here, you will have 3, 2. So give your answers as powers of x, you will have this and this. Or you can write this as what? 1 over 3 power 5. Right? So these are the two values of x for your answer for part B of question number 3. Now let's move on to question number 4. So here what do we have? A polynomial p of x is given to you by this equation. Where a, b, and c are integers are whole numbers, it is given that p prime of 0, when you take the value of 0, you get minus 9. Okay, so we have to use these information to show that b is equal to minus 9. Now, the first thing we have to know here is, what does p prime means? It just means that we take this value, we differentiate with respect to x. So p prime, it just means we have to differentiate this equation. That will become 3ax squared plus 26x plus bx. Now, according to the question, if this thing takes the value of 0, you will have minus 9. So let x be 0 and see what happens. So you will have p prime of 0. That will be 3a times 0 square plus 26 times 0 plus b, and that should give you minus 9. So this will be 0 plus b is equal to minus 9, hence b will be minus 9, shown as required. Now let's move on to question part B. It is also given that 3x plus 2 is a factor of p of x. So what does that mean? It means that if we take p of x, we divide by this, the remainder will be 0. That's what it means. Now, for what value of x does it happen? We take this one, we equate that to 0. So x will be equal to minus 2 over 3. So it means that when x is equal to this value, or when p of x takes in this value, the remainder will be 0. So let's form an equation. So so p, let's take in the value of 2 over 3. So basically we're replacing the value of x by this in our equation. This is our equation, so we have a, and then we have x cubed, so this cube will be minus 8, right, over 27, plus 13 times x squared, that will be, square will be what, 4 over 9, plus bx will be minus 2 over 3, and plus c, and that should give you 0 because the remainder is 0. Now we can try to simplify one by one. Obviously here we will have minus 8 over 27a plus how much? 13 times 4. What is that? Let's find out. That'll be 52 over 9 minus 2b over 3 plus c has to be 0. Now one thing is, I don't like to work with fractions, so what I can do is I can multiply everyone by 27, sorry. So I can remove all the base that we have in this equation. So this times 27, you will have minus 8a plus this times 27, so 52 over 9 times 27, that should be 156, minus 2 over 3 times 27, that should be 18b, and plus 27c has to be 0. So now we can form our equation, which is what? So here we have, obviously b has to be replaced. We know b is minus 9 already. Replace b. So b will be 156 minus 18 times minus 9. That should be 318. So here we have minus 8a plus 318 plus 27c has to be 0. So our first equation is 27c minus 8a. We send this over here, becomes minus 318. That is my equation number 1. Again, the goal here is to form equations so we can solve them simultaneously and then finding the values of a and c from that equation. Now let's move on. On the other side, for now, let's move on. So we also know that p of x is divided by this one. We have a remainder of 6. So for what value of x? We take this one, we equate to 0 to find the value of x. So when x is equal to minus 1, the remainder will be 6. So when p takes in the value of minus 1, replace in our equation, that will become minus 1 cubed is minus 1, that will be minus a, plus 13. Now here we have b is minus 9 times minus 1 is plus 9, and plus c, and that will give you 6 as the remainder. Now we just have to simplify, obviously. You will have c minus a has to be what? We'll send everything to the other side. You will have 6 minus 13 minus 9 minus 16. So finally we can make c become subject. So c will have to be a minus 16. Equation number 2. Now as you can see, we have 3 equations. We have to solve simultaneously to find the values of a and c. So one by one, let's replace c in this one. So 27, c is also equal to a minus this one, minus 8a is equal to minus 318. Simplify, that will be 27a. Here we have minus 8a. Expand this, minus. So 27 times 16, that should be 432. Minus 318. Simplify, 27 minus 8, you will have 19a. Send this over here. You have minus 318 plus 432, you will have 114. And a will be what? 114 divided by 19, that should be 6. So a will be your value of 6. Now what else? Again, you can see here, it tells you a, b, and c are integers. So if you get something as in fractions, you know it is wrong. It will have to be whole numbers, right? So finally find c. C will have to be a minus 16. A is 6 minus 16 will be minus 10. So from here we do realize that a is equal to 6 and c will be minus 10. So both are integers, which is a confirmation of your good answer. Now let's move on to part C of your question. So find the quadratic qx such that p of x is equal to this times this. So one by one, how can we do this? We know p of x is equal to what? Is equal to, we know the values of a, b, and c. Replace in your equation. It is equal to, a is 6x cubed plus 13x squared minus 9x minus 10. This is p of x. Now, we do know that 3x plus 2 is a factor. If we do factorize this outside, we will have q of x remaining. So we have to find q of x. Now, there's a few ways of doing this. I prefer doing this by long division. For example, I would say, let me take that equation p of x, which is 6x cubed plus 13x squared minus 9x minus 10 divided by 3x plus 2. So I can know the remaining of this operation. Now, to make 3x become 6x cube, I have to multiply by 2 first. So 3 times 2 is 6. X times x squared is x cubed. So this time this you will have 6x cubed, right? And 2 times this will be 4x squared. So this will cancel out, and this will become 13 minus 4 is what? Is 9. So let's double check, right? Yeah, you have 9. So you have 9x squared minus 9x minus 10. To make 3 become 9, have to multiply by plus 3. To make x become square, have to multiply by x. So now take this, multiply by this, you will have 9x squared plus 6x. Okay, so this will go away. Minus 9 minus 16, that will be what? Minus 15x minus 10. So finally, to make 3 becomes minus 15, have to multiply by minus 5. X is x, so same thing. So we have to multiply this, multiply by this, you will have minus 15x minus 10. And that will be 0. So from here, it is very clear that what happens? P of x is also equal to what? This thing multiplied by this thing, which is 2x squared plus 3x minus 5. So this is the Q of x we have been trying to look for. Now let's move on to part D of your question. So hence meaning using part 1, we have to find P of x as a product of linear factors with integer coefficients. So we just have to break this one into a linear factor. The reason why it is not linear is because we have x squared. This is linear because x is power 1. That's why it's called linear. We just have to factorize this one. So P of x expressed as a product, so 3x plus 2. Then we have to factorize the other equation as well. So 2x squared is 2x times x. 5 is 5 times 1, so I'll put 1 here and 5 here. I will try to get plus 3, so plus 3 have to be plus 5 minus 2. So we always take this one, multiply by this one, and this, multiply by this, and then we evaluate. So plus 5x minus 2x will be plus 3. So good to go. So this will be my answer for my factorization as a product of linear factors for P of x. This, times this, and times this. Okay, and that will be your question number 4. Now let's move on to question number 5. So here what do we have? We have a geometric progression. It is such that the 15th term is equal to 1/8 of the 12th term. So we can write this down as, we know the 15th term is equal to 1/8 of the 12th term. So we can form an equation with that information. But also the sum to infinity, so sum to infinity is equal to 5. Now since we know it is a geometric progression, let's write down all the formulas we know for that kind of progression. So the n term is given to you by what? I believe you also have a list of formula here, as you can see, geometric progression, right? The n term is given to you by a r n minus 1. The sum to infinity is equal to a over 1 minus r. So using those formulas, let's see what can we get for this. Now we have to find the first term, which is a, and the common ratio is r. So these are the missing values for this question part A. So let's use this. Or we can use this first, no big deal. So the 15th term, when n is equal to 15, replace, you will have a times r. 15 minus 1 is 14, is equal to 1/8, so 1 over 8. 12th term, when n is equal to 12, replace a times r. 12 minus 1 is 11. Now simplify. This and this will cancel out, obviously. We can send this one over here. You will have r 14 divided by r 11 is equal to 1 over 8. Simplify by the laws of indices. That will be r 14 divided become minus 11. That will be r power 3, 1 over 8. So r will be cubic root of 1 over 8. That should be 1 over 2. Here you go. Now what else? From here, we know the value of r. Let's see how can we find the value of a. Again, half is just 0.5, by the way, right? Now using the sum to infinity, as we have seen, the formula here is a over 1 minus r is 0.5 is going to be 5. Now we cross multiply. A will be 5 times 0.5, which is just 2.5. Hence, so finally, A will be 2.5 and R will be 0.5 for the common ratio and the first term of this progression. So the point is we have to use the given information. From that, moving on, using our formulas to help us find the missing values. Now, for part B, we have to find the least number of terms needed. So least value of n, for which the sum of the geometric progression is more than this. Okay, so one by one. We know that the sum of the first n term is given to you by what? Obviously, it is on your list of formula, which is a over 1 minus r. Now, one thing we can do first, no, this is sum to infinity, I apologize. This is sum to infinity, but what is the sum of the first n term? It is also given to you 1 minus this over n, 1 minus this. Okay, cool. Now we want to know what is the minimum value of n for which this sum will be more than this. Now, I hope the first half of the video was somewhat helpful. If you guys would love to access the full video, feel free to click on the Patreon link on the main page, or otherwise, you can go to the description below and click on this link to access the Patreon page for the full video. With that being said, good luck and thank you for watching.